Now this is where it gets a little tricky because now we have a lot of stuff kind of going on here, but we need to figure out what this angle of incidence is here. We need to figure out what this angle is. And it's not super easy to figure out, but we do have enough information to do so because we know that, use another color, this has to be 180 degrees. We have 80 degrees taken out here, and we have another 20 taken out here. So we have 180 minus 80, that's easy as 100, minus another 20, well, that's going to be, sorry, I cannot do math in my head, 100 minus 20 is 80. So this angle over here is 80. So now, making a brand new triangle, just to kind of make sure we're in the right focus, here's our triangle. We have 80 plus 20 plus 20. That's 120. And then how much is left of that? And that is going to be, and we need to get to 80, so that's going to be another 60, 180. So 60 plus 40 plus 80 should be 180 degrees to make us a triangle, because that's true of any triangle. Because this is not, we're not dealing with the right triangle here. So now we need to figure out, okay, well, what is the angle here? And this should be fairly straightforward, because now this has to be 90 degrees. So we have 60 plus what is 90 degrees, and that's going to be 30 degrees here. So that's going to, again, reflect back out at 30 degrees on the other side. So theta x2 will be 30 degrees, making it theta x1 is equal to 10 degrees, theta y1 is equal to 20 degrees, and theta y2 is equal to 30 degrees. And that does give us an answer choice of C. So you might feel like, well, there has to be an easier way. Well, AP College Board, they did come up with a way to do it in general. So they ended up that theta x2 would be equal to 3 times theta nx, which is greater than theta y1. And they have like paragraph reasoning, but personally, I understand math the most, so I just assigned this an angle of 10 degrees and went from there. This is not an easy problem, and I feel like they would just try to make it as hard as they possibly could. Okay, and then let's move on to the last one. Number 5, a wide beam of light is incident on a rough surface, as shown in the figure, where the width of the beam is represented as multiple light rays. If the rough surface exhibits diffuse reflection, which of the following best represents a beam of light after it's interacted? Well, diffuse literally means it goes in all different directions there. So it's not that it is not following the law of reflection, but we've got each light ray is going to experience something different when it goes ahead and hits those areas. So we are going to see a diffuse interaction. Okay. Thanks for watching. I'm trying to stop there.